To summarize the exponential function, it's really important to understand the formula. So that tells you where it lies on the graph, so on the top or the bottom. That's going to tell you how steep the graph is, and that is the shift up, the shift down, and also the asymptote. Okay, remember that b has to be bigger than 1, or a fraction that is positive. Can't be negative, can't actually equal 1, and definitely can't equal 0. Okay, so you're going to have, for a positive a value, you're going to have things that are on top pointing upwards, and for a negative a value, you're going to have ones that are on the bottom pointing downwards. Remember that your asymptote will dictate the shift of the graph. So if that is adding on numbers, you're going to have one of these graphs or those moved upwards, and if you're subtracting the q value, you're going to have a graph that shifts downwards. In terms of sketching exponential functions, there are two options illustrated here, one with a positive a value and no q, and here with a negative a value, a fraction for b, where there the b value is a whole number. Here you're adding on a q value. Okay, so just to revise, you're going to get the asymptote by looking at the q value, and if it's 0, then your asymptote is going to be your x-axis, and you're going to find intercepts where you can, and when you can't find an intercept, then it's because there isn't a q value there, so you won't have an x-intercept. When you don't have an x-intercept, you need to plug in a negative x value to get one on this side, and a positive x value to get one on that side. You can then join your dots. Don't forget to label the asymptote and label every single point that you plot. We need to be well aware of transformations with graphs when it comes to exponential functions. Remember that if you have one that looks like that, you're going to have it going up. It's going to be an increasing function. It's going to be on the top of the x-axis. If that gets reflected, it means that the y becomes negative because it's reflected in the x-axis and it flips over that way. Then you can have a decreasing function if it has been reflected in the y-axis, which means all the x's become negative, and that changes your b value into a fraction. If you reflect that in the x-axis, you get one that is negative with a fraction, and obviously it's also an increasing function. Domain and range are pretty similar to what you've done before in other functions. You're going to get anything for any x values because it can go any way, left or right, but your y value is going to be restricted by the asymptote. It's either going to be from the asymptote upwards or from the asymptote downwards. These graphs either increase or decrease for all values of x. So these two increase and these two decrease for all values of x. And lastly, finding the equations a little bit different to what you've done before, because there are three things that you will need to find. You could be given a partial formula, the asymptote, a y-intercept, or an x-intercept, or another point, or the origin. Just remember that even when you get given an intercept, there isn't a specific place for the intercept in this function. So it's not like the straight line graph where your q value is the y-intercept. It's not going to be that, but what you can do is sub in your y-intercept where x is 0 and whatever they give you for the y value as your x and y values into that formula, and exactly the same for the x-intercept, and exactly the same if you get it that it goes through the origin. It is merely the point 0 and 0. Remember that your q value goes straight into the asymptote.